Hi, grade 9s. Welcome to 3.2, Adding Rational Numbers. This is a big one, okay? Not going to lie to you, this is one that students struggle with all the time, but now is the best time for us to get some practice because these are going to be really important in grade 10 math. So, kind of seems odd, but multiplying and dividing rational numbers using fractions is easy, quite easy. It's the adding and subtracting fractions that are difficult. Adding and subtracting decimals aren't so bad, but adding and subtracting fractions are A, very important, and B, typically an area where students need some practice in. So I think it's the most important part in Unit 3. So make sure you understand this and you understand the processes of adding fractions and subtracting fractions, 3.2 and 3.3, for this unit. I think it's the most important part. Okay, let's just look at our example here. Marcel needs to lose a few pounds in order to wrestle in a particular weight class. 8 weeks prior to the wrestling season, the coach had him weigh in once per week to determine if he had gained or lost weight. And here are the results. So in the first week, he lost 2 pounds. In the second week, he gained a pound, lost 2 pounds, etc., all the way down to week 8. Over the 8-week period, did Marcel gain weight, lose weight, or stay the same? And how do you know? All right, well, let's just take the change in weight in words. Okay, let's take the change in weight in words, and then just write a little math beside it. So if he lost 2 pounds, he's at -2. If he gained a pound, let's just count that as 1. It's positive 1, but we'll just count it as 1. If he lost 2 pounds again, that's a -2. He lost another pound, that's a -1. Okay. He lost 2 pounds, so that's a -2. He gained 4 pounds, that's a +4. He lost 1 pound, and it's 0. So what we can do is we can add all these numbers together and get a final number, okay? So let's just look at, we can do this straight from here, okay? We can just do this straight from here, working this way if we want, or we can write it out separately as an addition statement. So I'll just do it this way first. We started at -2, and we gained. So if we're looking at a number line, remember, always look at the number line. If this is 0, and this is 1, and this is -1, okay, these are the positives, and these are the negatives. Okay, positives go this way, negatives go this way. So let's just keep that in mind as we're working through this. We started at -2, so we started over here. And then we gained a pound. Well, if we gain a pound, we're going back the other way 1. So -2 plus 1, we're at -1 at this point. Okay? So we're at -1 at this point. You don't need to do it this way. This is just me trying to keep track of where I am. So we're at -1, and then we go down 2 more. So we're already negative, and we're getting more negative. So we have to go further this way, which means our numbers have to get bigger going this way. So -1, going more negative, 2 more, now we're at -3. Okay? We're still at a negative number, and we have to go even more negative, so we know that number is going to be higher in the negatives. So -3 minus 1 more, we're going further to the left. So -3 minus 1 more is -4. And then we're still doing this. We've got -4. We're going more negative, so it's going to be -6. 4 plus 2, or -4 minus 2 more, -6. Now we're going the other way. We're way over here at -6, and we're adding a +4. Okay, so we need to jump 1, 2, 3, 4 closer to 0, which means we're not getting more negative. We're getting closer to 0. So this number has to go down 4. So now we're at -2. We weren't able to make it all the way out of the negatives, right? Because we were down at -6, and we were only able to make 4 jumps closer to the 0, which will take us to -2. Then, the 7th week, we go down a pound, so that means we're starting at -2, somewhere over here, and we go down 1 more, so we're getting more negative, so -3, and obviously, it didn't change in the last week if it's 0, so our answer is -3. Now, that's just one way to do it. You could have done it another way as well. You could have written it out as -2 plus 1 plus -2 plus, what's next? -1 plus, these are all addition, but when you're adding a negative, it ends up being subtraction, correct? -1, which one we're at? 1, 2, 3, 4th week, so I'm looking at 5th week, so that's -2, and then plus 4, and then plus another -1, and then plus 0. And if you add all that up, even using a calculator, you're going to get the same -3. Okay? So over the 8-week period, did he gain weight, lose weight, or stayed the same? He lost 3 pounds, right? That would be a loss because it's a negative. If it was a positive, we would have said he gained 3 pounds. How do you know? I'm not sure what else you could put there. I know because of math. How do you know? He lost more than he gained. How's that? He lost more than he gained. That's how we know he lost weight. So it asks us here to write these mathematical expressions using words like gains and losses. Okay, so started at 6 and then minus 3, which means, okay, if that's a loss. Loss of 3. Okay. Next one, -6 minus 3. It's still a loss of 3. I'm not considering the final answer. I'm just saying what's happening in the second part of this. How about C? -10 plus 13. Okay, well, in this case, he gained 13. So we're just considering the second part of the expression. Are we gaining or are we losing? We don't really care where we started. This person lost 3. This person lost 3 again. This person gained 13. So I find that handy to think about when I'm doing these expressions, when I'm solving these problems, is am I gaining or am I losing? And more importantly, looking at the number line, okay, which way am I going when I complete these steps? Am I going toward the positive? Am I going toward the negative? And which way am I stepping from each number? So let's evaluate. 9 minus 10 plus 8 minus 7 minus 4 plus 6. Come on, let's just do bed math. Let's make it easier on ourselves, right? Okay. We're not going to be doing a whole lot of brackets, exponents, division, and multiplication. We're mostly looking at adding and subtracting here. Okay. But this is important. Okay. Left to right. Okay. So if we're going left to right, we start here and we end up over there. We got no brackets, we got no multiplication, division, anything. So I find it easier. Let's just start one thing at a time. We got 9 minus 10. If we start at 9, okay, it's way over here, and we're subtracting 10. Well, if we're subtracting, we have to be moving left on the number line, right? So how many jumps do we make left? We make 10 jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because this number is bigger than this number, we actually go past the 0 into the -1. So 9 minus 10 equals -1, plus 8 minus 7 minus 4 minus 6. I'll just write. I'm going to go one step at a time. If your math is good enough that you can go a couple steps at a time, that's fine. But as always, show your work on the quizzes and exams because it's easy to make little mistakes. So now what have we got left over here? We've got a -1, and then we're going to add 8 to it. So this time we're starting here, and we're going to add 8 jumps. Well, if I add 1 jump, I'm at 0, and I have 7 more jumps to go. So 1, 2, 3, 4, 5, 6, 7. So really, these two are going to equal +7. I jumped from -1. Because I'm adding a positive number, I have to be jumping this way on the number line, all the way to 7. -7 minus 4 minus 6. Always everybody equals there. Well, this next one's going to be easy because I'm starting at 7, +7, and then I'm going minus, so I'm going backwards. I'm going this way, I'm going left. 7 jumps. Well, if I start at 7 and I make 7 jumps going backwards, I end up at 0. So this one's nice and easy. 0 minus 4 minus 6. Okay? And then we've got 0 minus 4. So we start at 0, and then we got to make 4 jumps backwards. 1, 2, 3, 4. That takes us to -4. Okay? And then I've got -6. Okay, now this is the one that students tend to make a mistake on. If I'm at -4, I'm over here somewhere, and I'm subtracting, I have to keep going more into the negatives, right? I'm losing, so I got to keep going further to the left. So I start at -4, and I make 6 more jumps backwards. I end up at -10. So mostly, I know you know how to add and subtract. So most of this is just keeping track of where you are in a number line. Where you are in a number line, and am I supposed to be going to the left? Am I supposed to be going to the right? And how much? It always helps me to think of this as jumps. You know, I'm jumping a couple this way. I'm jumping a couple that way. All right, next number. Bigger numbers, but it's really the same. It's really the same process. Let's just move from left to right, just like we would read this way. You know, let's go this way, right? So 110 minus 90. Okay, we're just using bigger numbers. 110 would be way over here, and then minus, which means I have to move toward the 0, and I have to move 90 steps. Well, if I start at 110 and I move 90 steps, okay, 110 minus 90 is 20. Okay, I start in the positive and I move toward 0, but I never get to 0 because it's less than 110, right? So I still am left at positive 20. I'm left somewhere over here on the positive side. Plus 92 minus 110. Okay, so 20 plus 92. I'm over here at 20, and I'm adding a positive 92, so I have to go way more to the right. So basically, I'm just adding these two together. And if you didn't have a number line and you saw 20 plus 92, at this point, all of you know what you're doing. I'm just explaining it using a number line and doing it slowly and in order so we don't make mistakes when we get to tougher questions. So 20 plus 92 is actually going to be 112. Okay, so that one is right there. And then we've still got minus 110. Okay, so we're at 112, way over here. And then we've got to take, because we're subtracting, we've got to take 110 steps, okay, back toward 0. So 110 steps gets us really close to 0, but not quite. Again, if I just told you 112 minus 110 in your head, all of you are going to be able to say that's 2. Again, the point of this was just to demonstrate addition and subtraction of rational numbers using a number line. And it's easy for you to do it with whole numbers, with integers, because I've seen you do it, 100 times already this year, and your elementary teachers have seen it for probably 7 years, adding integers. But we have decimals and fractions to deal with. So we're going to use the same principle, but fractions. You don't need to be afraid of fractions. Okay? You don't need to be afraid of fractions. A lot of students are, but it's probably because maybe they just didn't understand it in elementary school. And, if you get a little bit of fear in your head, I call it math anxiety. If you get a little fear in your head about one particular type of mathematics, it's tough to make that go away. But I'm telling you right now, you don't need to be afraid of fractions and adding fractions, subtracting fractions. We just have to follow the process. So let's always just remember to follow the process, take a deep breath, work left to right, and find a common denominator. This is the important part, and you'll be okay. So, to add 2 over 3 plus 1 over 5, we need to use a common denominator, right? Write the numerators as a sum of integers. Okay, when we're dealing with fractions, we cannot add unless these two numbers at the bottom are the same. Okay, so need to be the same. They just need to be the same, or we can't do the math. Okay, we're stuck. And in order for them to be the same, we need to use a common denominator. And that's just a fancy way of saying the bottom number needs to be the same on both. So we need to rewrite fractions. Rewriting fractions doesn't change their value, but it changes the way they look. And I'm just going to show you an example of this over here. Okay, these are the same. 1/2 is the same as 2 over 4. Just think about chocolate bars. Okay? If you only had 2 big pieces of your chocolate bar and you gave somebody 1, you gave them half. So you gave them 1 out of 2 pieces. If you had a chocolate bar with 4 squares on it and you gave someone 2 out of the 4 squares, you still gave them half. It didn't change anything. It just looked different because you gave them 2 squares instead of 2 slightly bigger squares instead of 1 smaller square. Sorry, 2 slightly smaller squares instead of 1 bigger one. Also, let's say your chocolate bar had 8 squares on it. If you gave your friend 4 of those 8 squares, you still gave them half your chocolate bar. It was just 4 slightly smaller squares. So they're all the same. They all equal the same, but they look differently. And that's the basis of what we're doing, is we need to make the numerators and the denominators look different, but mean the same thing. And there's a couple different ways we can do it, and lots of practice with these will make a big difference in your math anxiety. So let's look at the 2 over 3, and let's look at the 1 over 5. Well, 3 is clearly not the same as 5. What we can always do is multiply these two numbers together to get a common denominator. It's the easiest way to go if you're not sure about fractions because because you always get a common denominator. The problem is it's not always the best common denominator. So try to use the lowest common denominator. And if I look over here, okay, if I'm able to use 1 over 2 for the math question, I would rather use 1 over 2 than 4 over 8. Smaller numbers just means fewer mistakes. But in this case, let's just multiply the denominators and see what we get. Whatever we do to the bottom, you have to do to the top, okay? So that's a point that you should make there. Whatever you do to the denominator, you must do to the numerator. Otherwise, you're changing what it means. Okay? In order to go from half to 2 over 4, if I look at the denominator, okay, that is 2 times 2. If I didn't change the top, it would be different. If I just changed the bottom, the denominator, and made it 4, and I left it as 1 over 4, 1/4 is not the same thing as 1/2. So I've actually changed it. So whatever you do to the numerator, you also have to do to the denominator, and vice versa. So if I'm going to multiply the denominator, the bottom number, by 2, I also have to multiply the top number by 2. Otherwise, I'm changing the value. So let's look at this down here. So what we're going to do is we're going to do 2 times 15. Actually, sorry, there's one more step here. If you multiply, actually, I'm gonna sort of change my mind on it. You can do multiplying these two together, but what that really means for the numerator is you multiply this number, okay, by that number. So this one's going to be times 5, and this one's going to be times 3, and I'll show you why that works here. Okay, so let's just write this out down here. So on the top of this side, we've got 2 times 5. Okay. Now I need to multiply this by that as well. So this is 3 times 5. Okay. Now that's important. Look, I kept the 2 over 3, and the only thing I did was I multiplied both the top by 5 and the bottom by 5. So I change how these things look, but I didn't actually change the value of it. Okay? And you'll see that in a second. Now I'm adding to that. Let's look at the other side. Now I've got to add 1 times 3, okay, because this side's times 3, and 5 times 3. Ooh, 5 times 3, not 5 times 5. That's very important. 5 times 3. So I'm multiplying both the top and the bottom by 5 here. I'm multiplying both the top and the bottom by 3 here. By 3 over 3, right? So let's think about a fraction. I'm just going to go up here. Let's look at this one right here. I multiplied the top by 5, and I multiplied the bottom by 5. What does 5 divided by 5 equal? 1. If I multiply anything by 1, I don't change what the answer is. If I multiply, let's say I divide 3 divided by 3, like on the other side, 3 on the top, 3 on the bottom, that is also 1. So what we're doing essentially is we're multiplying both fractions by 1, but we're just making it look a little different. So because we're multiplying them by 5 over 5 or by 3 over 3, we're not changing the value, we're just changing the way it looks. So this, if we take it a little further, that's 10. 2 times 5 is 10. And then 3 times 5 is 15. And then we've got to add 1 times 3 is 3. Okay? And 5 times 3 is 15. Now here's the important part. The denominators are now the same. Okay? Denominators are now the same, which means we can actually add these. Here's the next big mistake students make. You need to avoid this. Only add the tops. Okay? Only add the tops. The bottom has to stay the same. So what I do is I write the bottom right away. So I'm not tempted to add those bottoms. I'm not tempted to add the denominator. Only the tops get added. So this is 10 plus 3 equals 13 over 15. and that is your final answer. Okay? Now, I know some of you are going to make that mistake. Some of you are going to go 10 plus 3 and then 15 plus 15, and you're going to get some wrong answers. Well, hopefully we'll catch those early in the first couple practice questions on the text or in the first quiz and get you out of that habit. Let's look at a few more examples, with adding some negative numbers and whatnot. We've got negative 5 over 8 plus negative 7 over 2. A lot of people like to write plus minus as just minus, and that's okay. If you want to keep the plus minus, that's all right too. What we need to do always is look at the denominators. Okay? We've got an 8 and we've got a 2. They're clearly not the same. Now, we could do what we did up here. We could multiply the 7 by 8 and we could multiply the 5 by 2 to get us a common denominator of 2 times 8 is 16. But if you want to kind of take the short route to these questions, just check to see if this number can fit an even number of times into this number. Because if it can, you can save yourself a lot of work. How do we turn a 2 into an 8 with multiplication? 2 times 4. So if I multiply both the numerator and the denominator on this side by 4, okay, there's a 4 up top and a 4 on the bottom, okay, I can actually make the denominator the same as this one without even touching this one. So that's the kind of the shortcut you got to look for on these. So I'm not going to touch this one. I'm just going to leave it as negative 5 over 8 plus, and then on this one, I'm going to do negative 7 on the top times 4, and then on the bottom, it's 2 times 4. There's a 4 up top and a 4 on the bottom. So 4 over 4 equals 1. We didn't actually change the answer. We just changed the way it looked. Okay, so let's take this a little further. Negative 5 over 8 plus, okay, now we've got, let's just put the negative in there again, just to keep us going in that same sort of format that we've got here. 7 times 4 is 28. 2 times 4 is 8. Okay? Now, some people will look at this and go, oh, I can simplify that fraction. I can make that 14 over 4, and then I can simplify it again, and I can make it 7 over 2. Well, you would just be undoing all the work that we just did. So try to resist the urge to simplify or to reduce your fractions till the very end. Okay, reduce your fractions at the very end. The whole point of us doing this, multiply by 4 on top, multiply 4 on bottom, is to get us to the point where these are the same, and they are now. So, as I always do, I'm going to write the denominator first, so I'm not tempted to add them. Okay, but I do need to add or subtract the top. Okay, so I'm at negative 5 on my number line. Okay, I don't have a number line handy here, but let's just say I'm at negative 5, so I'm on the left side. And then I'm adding more negatives, which really means I'm subtracting. So if I'm going further negative, then my negative number is going to get higher. So it's going to be 28 or negative 5 and then bounce 28 more times, still going left, which is going to give us 33. So it's a negative, lost my pen, negative 33 over 8. And what I recommend on these is, it's not wrong if you leave it as negative 33 over 8. But typically in the math world, we like to write anything that we can as a mixed number if we can. So because the numerator is higher than the denominator, we know we can write this as a mixed number. How many times does 8 fit into 32? Okay, or 33? It'll fit in 4 times, because 4 times 8 is 32, which is still less, right? So we know that this is going to be negative 4 as the big number. Now, what's the fraction going to be? Well, it's just what's left over. So if I do 8 times 4, I get 32. How do I get from 32 to 33? 1 more. So that's the top, and then the bottom is going to be what we started with, which is the 8. So the final answer on this question is either negative 33 over 8 or negative 4 1/8. I prefer this one. Ms. Shidalka does too. All right, let's move on to the next one. Let's separate my workout here. Negative 1/4 plus 2 1/6. This is important. You always convert mixed numbers into an improper fraction, which means it's got a higher number on top. We don't have to do anything to the negative 1/4 at first. Let's just keep it there. But we need to convert 2 1/6 into a fraction, which is going to be over 6. So I always write that out first too. It's going to be over 6, whatever it is. Now, if you remember, you just work backwards here. It's times and then plus. So 6 times 2 is 12, plus 1 is 13. There we go. 13 over 6 is the exact same as 2 and 1/6. And if you think about it, it makes sense, right? How many times does 6 fit into 13? It fits in 2 times. Okay? And if it fits in 2 times 6 is 12. What's left over? Just that 1 over 6. So that's how you go back and forth between improper fractions and mixed numbers. Okay, now we're actually at a question that we can work with a little bit, but we're still not there because we've got a 4 here and a 6 there. We know they need to be the same for us to add. So we're going to have to do a little work here. In this case, there's no way I can easily turn a 4 into a 6 using multiplication. It doesn't work, right? If I try 4 times 1, it's 4. If I try 4 times 2, it's 8, and it's already too high. So I can't do what I did over here. I can't do a short version. So let's just do it the way we did it before. Okay, let's take the denominator here. We're going to multiply both the top and the bottom by that number, and then we're going to do the same thing on the other side. We're going to multiply this by what's on the bottom here. So our question now becomes negative 1 times 6 on the top of this one, and 4 times 6 on the bottom. And then if we look at the other side, not equals, which should be plus. We're adding those fractions, I believe. Plus, and then on the other side, it's 13 times 4, which I believe is 52. 52. Oh, sorry, I'll actually write the 13 times the 4, just to be clear of all the steps I'm doing here. Right? Now, you can always check these at this point because you need to be multiplying by the same number top and bottom. So I'm multiplying by 6, that checks out. I'm multiplying by 4, that checks out. Because 6 over 6 is just 1, 4 over 4 is just 1. So I know I'm multiplying the whole thing by 1, which doesn't change it. It just changes the way it looks. Now I can take the math further, right? Negative 1 times 6 is negative 6 on top. 4 times 6 is 24 on the bottom. Keep the plus sign. 13 times 4 is 52 on the top. And 6 times 4 is 24 on the bottom. Now this is another check you need to do here. Are these the same? Because if they are the same, we're in the right direction. We made the right steps. If at this point these two numbers in the denominator are different, we made a mistake. So that's very important to check that right there. Now, because we've got the same denominator, we can finish our math. And remember, let's always just write the denominator before we start adding the tops, just so we resist the urge to add those two together. We only add the tops, okay? Only add numerators. Okay, only add numerators. So in this case, we're starting at a negative 6. We're starting on the left side of the number, but we're adding 52. So we're jumping toward the right because our numbers should be getting bigger. So negative 6, and then we're going to go negative 5, negative 4, negative 3, keep going. We've got to jump 52 times. All right, well, it takes us 6 jumps to get to 0. And then how many jumps do we have left? It's really just 52 minus 6, which is going to be 46. Okay. Now, this technically is the right answer, but we always, always, always want you to try to reduce your fractions. Okay, reduce your fractions only at the end. Okay, because if you try reducing them up here, then we get away from our common denominator, which was the whole point of it. We know that 46 is an even number. We know that 24 is an even number. Okay, so I know that I can divide 2 out of the top and the bottom. 46 divided by 2 is going to be 23. Okay, 24 divided by 2 is going to be 12. 23 is a prime number. Okay, so I can't do anything else to simplify this as a fraction, but once again, this numerator is higher than the denominator, so I can write this as a mixed fraction. How many times does 12 fit into 23? It fits in 1 time. It can't quite fit into, it's close, but it can't quite. So it fits in 1 time. Then you write the denominator, so you don't get confused. All right, now I go 1 times 12 is 12. How many do I have left over to get to 23? Okay, if I'm at 12, how many numbers do I have to add to that to get to 23? And the answer is 11. Okay, if this was 24 over 12, it'd be easy because 24 divided by 12 is just 2. It's not 24, it's 23, which means it's close. So So it's 1 and 11 over 12, and obviously 11 over 12 is very close. So this is the right answer. We will also accept this, but we prefer this one right here. So reduce your fractions at the end of the question and to try to write them as mixed numbers if you can. We're going to do decimals in a different video because this one's already at 30 minutes.